Okay, in the next video we will try to assemble this frame. It's probably the simplest part of this size. So first of all, let's open the back. And let's see what's inside. And I already have some garbage. So, I unpacked everything. First of all, most important parts of the drone. We have 4 arms. We have 2 plates, one bottom plate, one on the top of the drone. We have one more bottom plate, in fact, in order to fix the arms between this small plate and between bigger bottom plate. Pay attention that the second bigger bottom plate has injected and compressed nuts here already, and make sure that then we are going to use any kind of bolt. Pay special attention that this nut has a stopper, so bigger part of the nut is on this side and a small part of this nut is here, so it was probably compressed like from here to down, and it means that if we place the nut in a way, then we have smaller part of the nut here, potentially it can move the nut out of the plate. So always make sure that your bigger part of the nut is located on top. In this case, once we start moving your bolt inside this nut, and due to compression, it will just move it down, but there is a stopper already and it's not going to go away from the frame. So it's very important. So these 2 bottom plates in order to fix our arms. Once we have our arms, to add additional stability, we have 2 special plates that will help us to fix, at least make each pair of arms a little bit more stable with additional tension, and make sure that we have less vibration. This plate can help us a little. And if we are talking about upper plate, we are not going to use it until we finish assembly of the drone. Moreover, I already placed a rubber thing that is in the kit of the drone. Why it's important? Because then you're going to place a battery here, and once you have a nut here, if you don't have this rubber plate, it means that your battery will touch the bolts, heads of the bolts, and it will not be very stable in this case. So we definitely need this rubber plate here, and it helps us to use of the bolts with no issue, and our battery is not going to slip at all. So it should be pretty stable. Obviously, we have in the kit this strap in order to fix the battery. I'm not going to use it, of course, until I start launching my drone after assembly, of course, because it's like useless during, it's not a problem. You should not assemble it, you just fix your battery itself. That's why we are going to put it on site. We are going to put on site this upper plate as well, since we are not going to use it until we finish assembly of our drone. But all this stuff can be very useful. We have several smaller plates. 2 of them should be used, or can be used at least, to fix your camera. Not all cameras will fit this space. I believe that camera that we are going to use for XIR is not going to cannot be placed here. Let's see Yeah, so it's bigger here because it's I believe full mini size camera. Let me see. Mini, but we need micros. But if you are using Ratel Pro camera from Cadix, these plates can be very useful and you don't need any 3D print to place your camera there. We have two additional plates that are going to be placed on the bottom side of our bottom plate, and pay attention that these plates are using special placement for bolts with cap like this. Yeah, so if I put it here, you can see that there is no space between the frame and the top of the cap of the bolt. It's moving inside the plate, and the second bolt is here, and in fact it's something that we can start. Yeah, so we can put this plate on the bottom of our frame. Once again, from that side there we have smaller parts of our nuts that were compressed into the frame. So plate is going to be located like this, and we can fix these bolts using stands that you can find in the kit. All of them has the same length, so it should not be an issue to do this. And it should be like this. And obviously, yes, you need a key to do this in order to fix not this key, this one, in order to fix them a little bit. All the bolts that you are placing using for the bottom plate of your drone, of your frame, you can use a thread locker to fix all this stuff, but don't use thread locker for the top plate of the drone. Then you finally put it on the top side of the drone, because from time to time you are going to remove it, and to see what is happening, to probably remove some moss, to add some components, probably resolder something, and if you add thread locker it will be really hard to do. So usually I'm not adding any thread locker on the to fix upper plate of the drone. And another small plate that we have here should be located on the second part of the bottom plate, and you can see it has the same place for these kind of bolts, and we have just 4 bolts of this kind in our kit, so we can fix this plate. And have less components on the table. Okay, now everything looks fine, and we need to start assembling our arms. So bottom plate is going to be located like this, and it's symmetric. It's not important how you place it on the table, and you need to place your arms in a way. Then you have all these special locations for, I don't know how it's called even, for plates that fix your arms, moving towards inside the drone rather than outside. So because two of these arms are going to be fixed by this plate, and if you place them like this, for example, you will not be able to do this anymore. So that's why it's important to find all these arms and locate them in a way to make sure that you know how to fix them and finally place all together. So I believe it's going to be something like this. So it's going to be for the top forward part of the drone, and it's going to be like this for the backward part of the drone. Okay, so it's something how we are going to assemble it, and we cannot do it all together. Yeah, so what we have to do, we will just pick one arm and we need to find a boat that can potentially accommodate our needs here. So pay attention that if you look at this side of the plate, you will be able to see that one bolt should go into a compressed nut. Another bolt will just go outside of the plate and will be fixed using a stand that we have in the kit. That's why probably it's better to start with bolts that will go into this compressed nut directly, and it means that we should have 4 bolts like this. And let's see what we can use for this kind of task. It should be a bolt that probably once we fix our arm, it should should not go outside of the frame. So it should have the same level with this nut, and looks like that bolt size. So if you measure them in sizes, you can see longest one, next size after longest one, and one more size for the bolt. So let's say if we are measuring from the biggest size, it's size number 3. It's something that should accommodate. Let's do this. Should accommodate our arms and be good enough to fix the arm and don't go outside. I'm just not going to tie it much. I would like to make sure that my frame movable a little bit, so to make sure that all the arms can be placed with no issues and I don't have any kind of skewness or anything like this. But you can see, so bolt, probably it's moving outside, but just a little bit. It's very important because we are going to place some electronic components, and if you have drones that suddenly moves outside of the frame in random places, it can be hard to do. And the second bolt that I'm going to use here probably is going to be size number 2. So it's not still the longest one, but it's going to be long enough in order to fix the arm. Let's find a way to do this. No? And K can be helpful here. So you can see we moved it outside of the frame, and now we can fix it using the stand. Don't tie match once again, and now we can use all other arms to do the same. And this frame, frankly speaking, is the simplest one, because some other frames can be a little bit more complex to assemble, and you need usually 3-4 hands in order to carry everything in the right position. But this one, you can see, I can do it with no help, and it just like requires some patience from your side in order to move all these bolts into the right holes. Okay, went well. Went well and suddenly stopped, like, who knows. And you can see I made this mistake. I can say obviously that I made just in order to show you that you always have to remember that all this stuff should go into like center of the drone rather than outside, look at outside of the drone. So I need to move this arm now, and it's happening from time to time because you placed everything right, and after that you just moved your arm a few times in order to make sure that it can fit your holes, and suddenly you can see that everything is bad and you just fixed your arm not in the right position. And you make very similar mistakes all the time. Let's do it again. Okay. Oh, I even did not need to use my key, my wrench in this case, to start adding the stand. Okay, I believe it was the most complex part of assembly. Now you can just try to understand how to add all other bolts to the frame, what we are going to fix, and what we need to do with all this stuff. So probably we will start with the longest bolts. Longest bolts are placed here in order to carry your flight controller and ESC. And it's easy to do, we just need to rotate our drone. You can see this plate has bigger holes, so your bolt will just go inside with no issues, and half of the bolt you can move inside as well. And I'm just going to you can see it's moved. And as I mentioned, you can apply thread locker to the bottom plate bolts. I'm not doing it often because usually all these bolts are going to be in place, but there I'm applying thread locker. It's to bolts that are going to fix my motors. So now potentially you are able to place your ESC in this way. It's going to be in this direction, and you can see that it can accommodate our ESC exact. And what size of this plate? So distance between these bolts usually 30 by 30 millimeters, and pay attention that you're buying ESC, so when you're buying a flight controller for this frame, it's better to have 30 by 30, it's like a standard thing. Some ESCs have size 20 by 20, you can see small holes are here, so potentially if you have mini ESC, mini flight controller, 20 by 20, you can accommodate it here as well, but for 10-inch drone, I never saw a situation when people use any kind of mini versions. So 30 by 30, it's like a standard thing, and it can fit your frame with no issues. And flight controller is the same, it has the same form factor, 30 by 30 millimeters. So everything is fine here. We are not going to assemble, of course, camera plates. They are not going to be fixed by bolts. You just insert them into available holes and fix them by the bottom plate. That's why by the upper plate. Sorry. That's why usually we are moving them outside and put them in the same spot. There we have our upper plate. We are not going to use all this stuff till end of our assembly. At least some plates we can use when we start assembling our camera, but in my case I'm going to use 3D print. Now we need to finalize our bottom part of the frame using this stuff. You can see that in fact you can place this plate in order to fix arms, make sure that they are fluctuating less, like this, or you can potentially change their direction, rotate them and place underneath, like this. Since this frame does not have instructions and any instruction how to assemble it, usually I am placing them on top. Why? The primary reason, we have all the bolts here, and if we place this stuff on top, we will have all our bolt caps underneath. So it's something that we will try to do. We need to have 1, 2, 3, 4, 5, 6, 7, 8 bolts, and you can see we have 8 probably smallest bolts in the kit, and it's not something that we are going to do because they will not fit our frame height, but our frame thickness, but we can see that they're a little bit bigger bolts as well, and probably it's something that can help us to fix all this stuff. These small bolts we are going to use in order to fix upper plate, because upper plate is not thick, and you can see that small bolt can have much space in order to be fixed to our stands with no issues. So that's why we are not using smallest bolts from the kit. And now we have a problem. Yeah, you need to put it to somewhere and make sure that you will not lose them. So usually what I'm doing, if I'm not even going to add a plate here, I can just put these bolts into the stands here and leave them until we finally need to fix the upper plate of the drone. And it helps me to make sure that I don't lose them. So let's do this. Don't tie it, of course, just make sure that they will not fall just randomly. Done. And let's try to fix this stuff. So if I'm picking bolts that we have, or that finally left from our kit, you can see that we have enough amount of the bolt moving out in order to fix this plate. So let's do this. And once it's done, we need to make sure that we tie all the bolts here that we have, because probably we're not going to return to this part anymore and do it again. And obviously later we'll forget to do this. That's why tie everything as much as you can. It's better to use a screwdriver with appropriate tip, because you will be able to apply probably more force. But let's use this key as well. So, done. And we even have 3 bolts left here. And now we need to start adding components to this frame. And once we are ready, we will just attach this plate, attach battery on top, etc. And now I don't want to finish here, because it was a really simple task to assemble this frame. Now I would like to start assembling, adding motors to the frame as well. So as I mentioned, we are going to use Velox 3115 motors with 900 TVs, and let's see how to fix these motors to the frame. So what you have in the kit, usually with the motor, you have the motor itself, and you have this bag that includes several important components. And let's see what we have inside. It's of course useful to have scissors as well. I have it upstairs, so that's why I'm using just everything what I have here. And let's see what we have inside. We are placing propeller first of all, and you can see that motor at this part has some special surface that will not allow your propeller slip just because. So that's why you are placing propeller directly on this surface. After that, in case of the motor, they have a special plate that helps you to fix your propeller as well from the top, and you have a nut that you can use in order to finally fix your propeller. And that's all. You have a spare nut and you have a spare plate for this motor. I already have a box of this stuff, so but just preserve it just in case. And you have various bolts here. Let's see what we have here. So first set of bolts, they have it's like 7 millimeters, and the second set of bolts that we have here, it should be 8 millimeters. Yeah, so I cannot guarantee high precision, but it's like exactly 7 and 8 millimeters. The problem that if you measure our frame thickness, you can see it should be something about 7 millimeters. It even shows 7.25, but in fact we are talking about 7 millimeters at least, yeah. And 1 millimeter, if you're using bolts that has 8 millimeter lengths, it will not help us. It will not fix motor, because motor plate itself, let's try to measure it. It's not easy to do, but it's about 3 millimeters. So in perfect situation, 7 plus 3, we need a bolt that has 10 millimeters length. If you use 8 millimeters, it will go into this plate just a little bit, and it will not fix motor at all. motor will, sooner or later, it will just go away. If it's more than 10 millimeters, your boat will go outside of the plate from other side, and it can be danger. Potentially it can damage your motor. So always make sure that the end of your boat is not moving outside of this plate. In this case, this motor is situated a little bit higher compared to the plate. So it can be a little bit longer, probably 11 millimeters, probably even 12 millimeters. But in many motors, these windings are directly placed next to the plate that you're using to fix the motor. So pay special attention that your boat is not going to go outside of this plate, and to make sure that your motor works fine and don't produce any smoke. So that's why all these boats we cannot use, they are useless. You can see we have even more boats right now. You need a box to have all of them somewhere. We are going to use boats that I showed before that has length 10 millimeters. So we need to use 4 bolts per motor, and we are going to fix motors like this. Yeah, so all the cables are going to go in the direction of our arm, and finally we will solder to the motor controller in this area. So it's not hard to do. Trust me that when you assemble many drones, you always can find a situation that you just rotate this frame several times and can, by mistake, assemble your motor like this and finally see, okay, it's the opposite side of the drone. I did it a couple of times in my life. But let's try to do everything right. So we are going to assemble it from this side. What I'm going to do, I'm going to put one bolt here and try to fit, and don't tie at all. Your motor should be movable because you never know how all other bolts will fit or not your motor plate, so it's always wisely to have some flexibility. Okay, I could catch the second hole and third one, and finally last one. Okay, fine. Now we finally can tie all these bolts, and you can see all previous Allen keys that I used before don't work. I need another one. Let's see what I have here. This one, yeah, I believe. And in this case, I strongly recommend to use bull thread locker that we already discussed. It's very important here. I'm not using it to just save our time, but just put a little bit of the thread locker on the thread of your boat and fix your motor finally with your boat with this solution. And if you look here, you'll be able to see that no bolts are moving outside, so 10-inch is good for this frame and for these motors. And always make sure that everything tied very well, because imagine number of rotations and vibration, etc. So you can see that our frame is ready and we already fixed the motors. The only thing that I would like to do is prepare these motors for soldering, to solder all these cables to the ESC. And in order to do this, it's better to fix these wires with ties. I'm usually using 2 ties per arm, and one here and another one is going to be here. Try to make sure that all your cables are perfectly, and obviously you can add some tension. We are not going to remove them later. We are going to leave with the drone all the time to make sure that our wires are not fluctuating, and we need just make sure that everything is pretty well fixed. And now leave probably a couple millimeters and cut them. These couple millimeters from one side are very important to make sure that our tie is not going to be loose. From another side, pay attention, it's like very sharp and you can hurt yourself. So always remember that you have some sharp edges here. And I did ties in a wrong way right now. You can see that one sharp edge is moving this direction, one sharp edge is moving this direction. Probably we can accommodate them to make sure that they can look at this direction and probably even the downside. But it's up to you. And we will do the same with all the motors. And we're done for today. What we are going to do next time? Next time we are going to attach ESC to our frame, and we are going to attach our flight controller. Make sure that everything is working fine. But probably first task that we will need to complete, add pair wires to connect battery. And at the end of the video, I would like to share some notes about frames and potentially motors. So I already mentioned last time that this one, I believe it's the biggest drone that going to be in a range $500-700. It's the cheapest one. Everything what is going to be bigger going to use a little bit different frame. So imagine you have 13-inch drone, for example, and if you have so long arms, probably if you cut them just from a sheet of carbon, they will start bend a little bit. It will the construction will not be stable. It will be vibrating probably. I know some people are trying to build even drones like 13-inch drones with this design, but I would not recommend this. I believe like 10-inch is the biggest one. Everything which is bigger, and even for 10-inch drones, you probably need to use not this kind of carbon frame. And you could see that we spent like 30 something minutes in order to assemble it, including motors. But you need to use carbon tubes for your arms. But once you start using carbon tubes, it means that you have to attach to them special components in order to fix motors, in order to fix this tube inside the frame of the drone. Frame is going to be definitely different, and you have even like for this small part, you have 1, 2, 3, 6, 12 bolts, and I'm not talking about bolts that we are going to use in order to fix motors as well. And you can see for this small part you have 4 different carbon plates and two metal plates as well. So it's like not very complex from one perspective. From another perspective, it's going to be much more expensive compared to this basic frame that just somebody cut from a sheet of carbon and so on. We just use few bolts in order to assemble it. And that's why, yes, it's the biggest drone. And once you start build bigger drones, or even 10-inch drone, but with probably better qualities, you need to use carbon tubes. And moreover, if your arms are longer, obviously for bigger drones, you need longer arms. You will need to accommodate your ESC somewhere inside probably the tube or outside, but probably you need to fix it somehow and probably build a component that will try to protect ESC from water, for example, from rain. And it means that you cannot use 4-in-1 ESC. So construction of this drone will be much more complicated compared to that one that we are going to build. You will need to use a separate ESC per motor controller, and due to longer wires, you will need additional capacitors to make sure that every arm has a capacitor at least per 15, probably 20 centimeters of length, depends on the size of your drone. And obviously, you will need more expensive propellers and expensive motors. So that's why if you look at some kits that propose drone frames that range from 15 up to 70, 20 inches, you can see that these kits usually, if we are talking about ready-to-fly kits, it's usually about $1,000 per drone. And it's something really basic, and you still need to add some additional components, etc. That's why, yes, we are developing this drone. And if we are talking about motors, you can see that I'm using motors from T-Motor company. And usually picking a motor, you can see specification and you can see for which kind of drone this motor has been recommended. So for this one, you can see that it's recommended for 10, should be somewhere in the description, for 8-11-inch drones, and you can use drones like quadcopters with 4 motors, or you can use 8 motors and still use 4 arms only, but each arm will have 2 motors on the top and on the bottom in order to carry really heavy payload. I'm not sure if it's like really good idea, because your motors will consume so much of power from your battery. It will need much current, and probably you will need to install kitchen set not one, several batteries, and your 10-inch drone is too small for that. So if you're going to carry really heavy payload, probably you need the bigger drone. But in this case, you can see that it tells that this motor can carry up to 5 kilograms per motor, and we can tell, oh, fine, we have 4 motors and it should carry like 20 kilograms. Not so true. So if you go to specification, so we have to care about 2 parameters. First parameter, it's throttle, and if you would like to understand how much payload your drone will be able to carry, look at 50% of throttle. It can guarantee that, okay, if you have this payload, you can fly with no issues, and you can do almost anything in the air. And if you look at 100% thrust, you can see, oh, yeah, really, this motor can carry potentially 4.2 kilos. But we are not talking about flying. We are talking about, okay, it potentially can just sit in the air for for an amount of time in like really critical situation. And it doesn't mean that it can fly with this amount of payload. So in case of our motor, we can see that at total 50%, we have payload 1.4 kilos. It means that for 4 motors, it's like 5.6 kilos. And if you're building a drone that should weight with a battery for about 2 kilos, we can assume that our drone can carry about 3 kilograms with no issues. And it's exactly what we are trying to achieve. So that's why we picked exactly these motors. But you can see that company tested this motor with different propellers. And potentially you can say, oh, why we are using this propeller 9.5 by 5 by 3 rather than, for example, this propeller, the 10.5 inches. And the answer is very basic. We have to look at the second parameter. The second parameter is amount current, number of amperes that motor will consume from your battery and through motor controller. And you can see that for this propeller, in the most critical situation, I don't know then, but imagine we just catched another drone with a net and trying to force it moving into a separate, different, opposite direction, and probably will consume 70% of power. And in general, we're assuming that we are going to fly like somewhere in this range, yeah? But imagine, we need to make sure that our ESC, our motor controller, can survive under this pressure. And if you look, for example, at another propeller, you will be able to see that at 100% of throttle, it's consumed more than 80 amps. And in our case, we are using this ESC, and this ESC continuous current supports up to 65 amperes per 4 motors, 65 amperes per each motor, so by 4. And burst current, like maximum one that it can survive probably for a couple of seconds, 75 amperes. It's still not enough. It's still better to have an ESC that can have additional capacity to make sure that everything is really smooth and stable. But it's really hard to find a ESC that has 80 plus amps. This one looks the best from price and capacity perspective. So we're assuming that we're not going to fly our drone at 100% of trust. Yeah. And that's why, yes, we're picking this propeller because, yes, probably it's not going to fly as fast as if we're using this propeller. But it's not going to burn our motor controller in this case, and I'm using this schema many times already, and everything works fine. Yeah, so I used it. And that's why I'm recommending exactly this propeller for this motor. Okay, in general, you can buy another motor. You can find some motors on the market with very similar parameters and sometimes cheaper, but in some cases, they are not able to carry as much payload as they provide in their specification. But at least we're not going to burn your ESC in this case, and can fly if you don't need really big payload for your drone. You can just use another motor. And probably that's all. Yeah, so pay special attention every time that you're picking motor. Pay special attention on amount of current. Pay special attention to payload that it can potentially carry at 50% of throttle, and everything should be fine if you just go from these parameters. Thank you.